Hello students, today we will continue to study the afterburner part. In this class we are studying the second section of the afterburner. Because the basic components of the afterburner are complicated, it is divided into two parts. The first part is to distinguish the basic components of the afterburner 1. First, look at the picture. Taking the MA202 afterburner and nozzle as an example, some basic components are listed. Among them, the more important parts marked in red include the oil transfer ring, diffuser, igniter, and flame stabilizer. Below are the names of some basic components of the afterburner. We will explain them one by one in the following order: diffuser, flame stabilizer, oil transfer ring, and fuel nozzle casing and ignition device. First is the diffuser. The function of the afterburner diffuser is to reduce the speed of the airflow entering the afterburner and stabilize the combustion. It is generally composed of an outer wall, a rectifying cone, a rectifying support plate, a heat shield, etc. Its inner cone is usually made into a truncated cone, which shortens the cone length and makes the airflow suddenly diffuse at the end of the truncated cone, generating turbulence and forming a reflow zone that is conducive to stable combustion. Then, there is the flame stabilizer, which is also the focus of this section. Its function is to make the airflow turbulent, form a recirculation zone, accelerate the formation of mixed air, and strengthen the combustion process, stabilize the flame, and improve the degree of complete combustion. There are generally three types of flame stabilizers. First, V-groove flame stabilizer, also divided into annular stabilizer and radial stabilizer. Second, Dune vortex flame stabilizer. 3, evaporative flame stabilizer. We mainly introduce the first two. In the afterburner, non-streamlined objects are usually used as flame stabilizers. The most common one is the V-groove, which has the advantages of simple structure, light weight, small loss, mature development, and good performance. The WP6 engine uses a single-row annular stabilizer, which consists of a V-shaped ring, a V-shaped support, and a support. The 6 V-shaped supports are used to support the V-shaped ring and transmit the flame. In order to enhance the rigidity, double-layer plates are welded on the edge of the V-shaped plate. The entire stabilizer is bolted to the mounting seat of the rear oil transfer ring through the support. In order to solve the problem of low-temperature, stable combustion, V-groove, radial flame stabilizers are widely used. Note, V-groove flame stabilizers stabilize the flame by generating a turbulent zone behind the stabilizer, which will inevitably cause flow losses, and this effect still exists even if the afterburner is not working. The Dune vortex flame stabilizer is a device used to improve the performance of combustion devices. Its design is inspired by the unique fluid dynamics of crescent-shaped sand dunes in the desert. The ability of these dunes to maintain their shape in strong winds inspired Chinese scientist Gao Ji to invent the Dune vortex flame stabilizer in 1981. The shape of the sand dune vortex stabilizer is close to streamline, so the flow resistance and loss are small. It also has strong anti-interference performance. The experimental results show that, under the same blockage ratio, this stabilizer has 3 advantages over the V-shaped groove. First, the resistance is reduced by 75% to 80%. Second, the lean flameout limit of combustion in the vortex is extended by 4 to 5 times. Third, the ignition wind speed is increased by nearly 1 times. Professor Gao Ji used his keen insight and bold innovative spirit to develop the Dune vortex flame stabilizer in the harsh conditions of desert. This achievement is inseparable from his persistence and hard work in the difficult environment. The invention of the Dune vortex flame stabilizer is of great significance to the field of aviation engines. It not only improves the thrust of the engine, but also greatly improves the qualification rate of aviation engines. Students, in this class, we learned about the basic components of the afterburner. In the next class, we will continue to introduce the relevant knowledge of the basic components. Students must master today's knowledge in a timely manner and apply it to other situations.